Hello world, hello internet, and welcome to the second episode of the 2023 Nix Developer Dialogues. I am Valentin, your host. My host name is Frickler Handwerk. And if you have no idea what all of this is supposed to be about and you're watching the recording, I recommend you to check the first episode where I provide a little bit of context on this series. Today will be probably quite a bit more technical than the last episode, but it's still supposed to be primarily about people and stories and how you can be part of these stories. Therefore, if you have any questions along the way, please send them to us on any of the channels this is being streamed to. We also have a Matrix room, which is linked in the show description in the calendar event for this show. And if you want to be part of the show, part of the stories, then join the studio and I will put you on the air where you can ask questions in person. That will be great. Now let's jump right in and welcome our guest today, Ryan Lahfa, known as Raito Bizarius. Hi, let me put you on stage.
Hello everyone. Nice to be here.
Welcome, Ryan.
Thank you,
Good
Valentin,
evening.
to have me. Good evening,
Yeah,
yes.
great to have you here. We have a little bit of delay. Sorry, I have the feeling I'm talking into you. This is live. Well, okay. Today, you will probably have to explain quite a few terms our audience may not yet be familiar with. I will stop you if you go too fast. Feel free to go as fast as you want, though. And the first one will probably be our main topic for today, convergent configuration with NixOS. But before we get into that, let me introduce you a little bit. So you describe yourself as an eternal student of math and computer science. And one of many of your interests in computing are formal methods. You've been part of the Lean community. For those who don't know, Lean is a proof assistant and computer security. So you've been recently working on quite a bit of stuff around security in NixOS, and we will talk about that today as well. And you've been part of the Nix community for a couple of years now, but you became a lot more visible once you took upon yourself the task of directing the 23.05 release of NixOS. And we will talk about releases today too. You have it in your title string here. The 23.11 release is coming up quite soon, so that will be a topic today as well. And well, among many other things, you also co-organized NixCon 2022 and 2023. So to say the least, you're quite involved in the Nix community. And I hope you will tell us more about yourself when you answer the first and obvious question, who or what got you into Nix to begin with, and why are you still here?
So the nice story about why I got into Nix is someday a friend of mine came to me and described me, told me about this Nix hype thingy, and then I asked what is it useful for, and then described me a bunch of impossible things. So like every people like me would do, we would take this impossible technology, use it, and see if it is doing what it has promised. And the crazy thing is, oh, it worked. Then shortly after, I was addicted to Nix and NixOS and nixing everything possible around me. That's pretty much it.
Well, what were these impossible things?
So I think the idea was to say, when you are on a normal distribution, on a classical Linux distribution, when you upgrade your things, you get breakages because you cannot have multiple versions of the same software, etc. And I was like, this, in my mind, it was an impossible problem to solve. But then when I looked into Nix and I've seen this very simple idea of saying, let's just break compatibility with everything, I was like, oh, that's a way forward, right? That's an interesting minor evolution of the Unix model. And yeah, I got addicted on that.
Let's talk about those releases. So first, a bit of context. So Nix packages and NixOS live in one giant mono repo. And what's the process of when contributors add their commits to Nix packages, and between that and that code arriving on users' machines? What's happening there?
So I would say there are. So first thing is that we have multiple branches. We have multiple supported channels of NixOS. We have the unstable and the stable, to be simple. But then even in unstable, we have unstable and unstable small. And in stable, we have stable and stable small. When you push commits to master, or you push commits to a release branch, 2305, for example, your commits are at some point sent to our build farm, which is hydra.nixos.org. and where we evaluate what is new to build, and we build it. And then we have something that I would call acceptance test that will run using that bunch of commits. And if the acceptance tests are okay, then we have what we call a channel bump. And that's the moment where your commits are available to end users, and end user can upgrade their NixOS machine to pick them up. Acceptance tests can be anything like, does my NixOS VM still boot? Can I still encrypt with ZFS? Can I still do like expected features that you want to have with a NixOS system? Those are basically integration tests. That's, I would say, the process from merging that commit into master or NixOS 2305 and having it on your end user machine.
That does sound quite involved. So it's a bit more than just branching off master and calling it a day.
Yes, absolutely. Because I didn't touch upon that, but because of the way NixOS works and Nix in general, you have to rebuild every dependence every time you touch a dependency, right? So if you touch systemd, if you touch GCC, if you touch any very, I would say, low-level dependency, you have to rebuild everything that depends on. That means that we have to be a bit careful. We cannot rebuild the word every time we do a commit. We have to do something like batching commits together and testing them together. That's the role of the staging branch, for example. And so because of those many aspects, um, cutting a new release is not very easy. It has to take into account the multiple, I would say, risky area. If you upgrade the desktop environment, you have to check that the whole desktop environment ecosystem, for example, GNOME, is still working as intended. Um, Same for anything related to, I would say, compilers. If you upgrade your compiler, you have to verify that your new compiler still compiles everything that was compiling before. So there is a lot of testing involved here. Yeah.
How long does it take to run an entire build of the everything?
So it depends on what type of machine you have at your disposal, but um, like for example, it took me something like 2 weeks to rebuild Nix packages on a single, very fast EPIC 7763 64 cores machine. Um, I think Hydra can do it in maybe 48 hours because it has a lot of x86 machines at disposal.
Okay. But since that process is done for every commit on master, if I understand correctly, what's the purpose of having stable releases at all? Like, couldn't we just do the Arch thing and like roll?
So I think that's what is. I think I would say this is what is nice about NixOS. We like when you have the rolling release mechanism, having the stable release mechanism is not very much it's not much more expensive. You just say at this point I cut a release, and then I tell people to use that git tag, and this is called NixOS 2305. The important thing for why we need a stable release is that um, well, users deploy NixOS somewhere, and NixOS rolling release moves super fast. So sometimes we remove packages because they're end of life, or they're not secure, they're not maintained, or they're not compatible with the rest of the tree. Many reasons for why the rolling release is too complicated to follow for other users that have a different pace. So it benefits mostly users, but also yeah. I mean, I run on my servers a stable version of NixOS, and I run on my laptop and desktop a stable version of NixOS. It's a very simple form of long-term support.
Talking of long-term support, how does that work? So how long is that long-term support to begin with?
So an NixOS release is supposed to live for 7 months, I think, practically speaking. And in practice, it's more or less 7 months. So we have 2 releases per year. A release is done every 6 months. So it should cover, the whole year, basically.
Okay. And what's the reason why the support is so short in comparison, for instance, to Debian?
I think the hard thing is that The nice thing about a 6-month release is that your branch doesn't diverge too much from the unstable one. It's just late off 6 months basically. And during the process of doing the new release, the next release, we backport a lot of things to the previous release. So the divergence between the previous release and the next release should not be very big. If we wanted to do it like Debian or having like a more long-term support thingy, we would have a much higher divergence of the previous branches that would cause a bigger churn on the contributors, which are not, I would say, responsible for ensuring that a package is going to be supported for the next 5 years, right? Most of our maintainers are not very necessarily in touch with upstream. They're not expert of the package we're maintaining, and asking them to do this can be quite hard.
Okay, and who is working on that? So who are these maintainers, and who would be responsible if you wanted to help out with, since, say, backporting versions to prior releases?
So theoretically speaking, if you take a package and you look at the maintenance fields, those are the maintainers responsible to backport things and to handle unstable workflows. So a maintainer is supposed to handle backport to stable and unstable work. If you want to help to backport more things, there is no real, I would say, role that takes care of that. There's only that takes care of security updates to stable, but we do this by pinging the maintainers themselves. um, but that's quite open. Like it's an open question, and anyone who wants to solve this problem can just join the maintenance and join the contribution channel and ask about how to get started on that.
Okay, so what's going on with the upcoming release 23.11? Do you need help there?
So I think I don't know what to say about release in general. Like there is no pattern in my opinion because it's hard to generalize thing. So this release is interesting because it has a lot of it has this very famous GNOME 45 feature that we expected. I think it's not there yet. Um, by the way, apparently the whole release process was engineered to like sync on the GNOME release process, so that we can still have like the GNOME new release at the time we do the new release. So this release, we probably will have some troubles with getting the latest GNOME, but maybe not. That's open. We had a lot of trouble with infrastructure. We had ARX64 Linux shortage in our build farm, and ARX64 Linux is high tier platform, so that means that we block channel moves if ARX64 Linux didn't finish to build, which means that basically we had a lot of building that was paused, that was blocked because we didn't have enough capacity. But that's true of other things in infra, like we had trouble. So the staging process shifted a bit compared to the schedule, but thanks to the amazing work, and I want to give a big shout out to the staging people and the infra people, I think like we caught up with the schedule. Tomorrow is the branch off, so I think we will enter into the real what I would say zero Hydra failure phase. We will ask everyone to participate in this funny event where we just squash bugs for the next 2 weeks. And we backport any fixes to the stable release the stable branch that will be branched off tomorrow.
So the branch off is tomorrow, you say?
Yes.
Okay, and
7
how
p.m. UTC. 7 p.m. UTC.
good to know. How do you how to best help? How do you figure out what one can do to help with ZHF?
So we have this website zh.file, which contains like the graph of failures, like and it's updated every time Hydra fills it should update it. And you can filter by maintainers, you can filter by the packages that creates the most subsequent failures. So if you have a dependency that fails, everything depending on that fails. So I would say the best way to get started is to look for this list and find a package that you care about or you understand, and then try to run the test and reproduce the failure. Then try to like the first thing you should do, no matter what, before anything, is to check if there is no peer fixing that problem first. Once you determine that, you can start working on a fix, and you can send that fix. and you can put the maintainers of that package or NixOS module as reviewers, and you can put the tag, or you can just mention the issue of zero hydra failures, so that people who focuses on zero hydra failure, which should be everyone, I hope, will pick this up very quickly.
Okay, I happen to know a few people who will have an entire hackathon next weekend in Zurich, squashing zero hydra failure bugs. So you're invited to join at the OST. Small plug from my side here. Oh, yes, I'm sorry. I made a typo in the HTTPS, of course. I'm sorry. Yes, and I suppose that there will be many more hackathons around the world to make zero hydra failures a success. What's the deadline for releasing?
So I think the idea is that you release on the last day of the month. So if I pull the schedule, we're supposed to end zero hydra failure on the 29th November. So that would be the release target.
Okay. Are there any questions from the audience? You're always invited to send anything that you want to know about in the channel. Here I see some somewhat unrelated, but we'll still answer it, about memory on search operations on Nix. Do you want to answer this? I'll just read it out loud. My Nix consumes a lot of memory. It crashes on my machine with 4 GB on search operations. What can I do about it?
We have this tooling called Nix-locate. So this Nix-locate doesn't need to use the classical Nix search operations, which requires to do evaluation of Nix pages, and it is the source of your out-of-memory problem. Nix-locate relies on a pre-computed database of all the paths in Nix pages. So it should run with a lot less memory requirements, and that should fix your problem.
But you may have to pre-compute a database, right?
Yeah, but we have a GitHub action that compute the database for you every week, I think. And so you can just download the database. You don't need to compute it yourself.
Okay, thank you. I hope that answered the question. Thank you very much. Let's talk about security. So very generally, I mean, many people have largely vague conceptions of what security is even about in computing, and especially what concerning Nix and NixOS. What's the state of security in NixOS, say?
So it's hard to get a feel of where we are. I mean, everyone has their own definition of security. And so some people like me work on boot security features. Some people will work on package security updates. That is the responsibility of every maintainer plus the security team. There are people who are aware that we have vendoring issues with our packages. If you take an Electron application that is built, that we download from a website already built, that is not a source build, but a binary built package, we have no idea of what dependency went in there. And there could be some dependencies that are vulnerable in the package that we cannot trace back to our own source build stuff. So I would say the state of security is that we have a lot of things. I would say that we are in a better position every new year. We're in a better position. We do better at the job. It's hard to compare to other distribution because Nix packages is a bit special. We accept too much packages, I would say, and that has a consequence on what type of problem we're trying to solve. If you take a Debian distribution, for example, you will usually get your packages via the language ecosystem package manager, so pip, npm, or gem if you're using Ruby. But on Nix packages in NixOS, you're encouraged to use Nix and only Nix to do your things. That's quite different, and it means that we have our own challenges about how to ensure the security of the language ecosystem packages. And that's super hard. But what is interesting to me is that I feel like we have a lot of open problems regarding security of a distribution, Linux distribution, and this community is taking them head on, and that's quite exciting.
Okay, you said we're working on improving that. Who are we? Who are the people working on security?
So I would say generally the security community, not to confuse with the security team. So the security team is like those named people who are responsible to do the calls on security matters in NixOS. But there's much more people involved into doing security work in Nix packages on a daily basis. For example, the maintainers of any package is part of the security community because if there is any security problem of their own package, we expect them to fix the security problem. Then you have people who are maintainers but also work on providing tooling to the security team, providing tooling to the security community. So they build open source software surrounding the ecosystem of Nix packages. You have the security tracker work that we are working on, you and me. And we have, for example, in the past we had Vulnix, which were responsible to do vulnerability roundup inside of Nix packages. So I think a lot of people are involved into security, if not almost everyone, and that's a good thing, I think.
You've heard it, people. You're also part of security. Brian has a question. I've heard you're working on secure boot support for NixOS. How's that moving along? So first of all, what is secure boot support? What is secure boot?
Yeah, so secure boot is a feature that you can use on I would say normal systems that enable you to sign the boot files that you're using to boot your Linux system. So you need to sign them with a key, you need to have a key infrastructure and so on and so forth. But the most important thing is that it prevents someone from swapping your kernel and your initrd and to lure you into booting something that you don't expect or you don't trust. So if you leave your laptop in your hotel room, you won't come back with a backdoor NixOS system, for example. That's the very simple idea behind secure boot. So this support is the project that supports secure boot in NixOS mostly is Lenza Booty. It is a Nix. It's I would say the support code that you need to have secure boot support in NixOS. It's a bunch of NixOS module and Rust programs that enable you to install support secure boot on your NixOS system in a user-friendly way. We are upstreaming this project into Nix packages, and this is the second time I try to push it inside of the release. Unfortunately, it seems like that not a lot of people have tried to compile to UEFI platforms. That is required because UEFI is the platform view that you have on normal systems that support secure boot, and there's a lot of things to invent here. Even LLVM upstream compiler does not support that target very well. It only supports a hack where you compile to Windows and you say, oh, Windows is like UEFI, etc. So there are a lot of setbacks, unfortunately, but I'm hoping to upstream this for 2305. In the meantime, you can already use it out of tree. You don't have to wait for Nix packages to have it, but that's the goal. You're asking also that you want to ask the next question?
No, I would go into some detail here. So you say currently you have to invent a lot of things. Currently, if you try to start NixOS with TPM enabled, it will just fail, right?
No, it works. So TPM2 story works for now, but you cannot use it in a very interesting way. You have to write your own code to make use of that. An interesting thing we would like to do with the TPM2 is we would like to have the NixOS module credential secrets handled by the TPM2. That requires to use a system feature called load credential encrypted. And so it's kind of already possible to use it without more code for any user space NixOS modules. But imagine you want to boot a SSH server before you mount your root partition. So what we call in the initrd, in the stage 1 of the boot. Well, if you try to do this, you need to pass your secret before. And to pass your secret before, they have to come from your boot partition. And if they come from your boot partition, you need to have some, I would say, extra code to manage, to gather them up and send them inside the initrd. That's the work we're doing right now with the TPM2 in Lenza boot. And if we have this, we will have a pretty nice story for using TPM2 for systemd secrets.
Okay, but since you still have to invent these things, do other distributions actually have this already?
So that's the fun part. As far as I know, not a lot of distributions are using those features. That's also true of a lot of systemd features in my experience. The thing is that distribution that focuses on image-based distribution, image-based operating systems, they have those type of features because that's the first thing they come for and the first thing they focus. But the image-based distribution is not necessarily an operating system that you can run on your laptop. because it's not very convenient to reimage your system every time you install a package, for example. I think.
What are examples of image-based distributions?
So you can take, I think, you can take any embedded operating system. So, for example, something that is based on Yocto Linux. You can take something that is based on Fedora Silverblue. And then probably OpenSUSE Micro OS is image-based distribution. And they all use a form of OS3 feature, and they build things comparable to what NixOS is, but while preserving this compatibility feature with the file system hierarchy standard. So yeah.
Okay, so that sounds like a quite unique feature that you're coming up with slowly, incrementally, right?
Yes, so I think where we are right now is that we are building a lot of unique features in NixOS, because like we care about the fact that people are using their laptop and they're installing packages and they're modifying their system, and that's usually the hardest thing to deal with in security ecosystems. If you have everything immutable and nothing can ever change, that's super cool. You don't have to care about changing things. But whenever you start thinking about the Nix store can change, security-wise, this becomes a bit harder.
Yeah, the worst part are the users who constantly try to tinker with their machines. It's terrible. So
Yes.
Brian has another follow-up question. So can I expect the NixOS installer to launch from Secure Boot in the future?
So that's another project we're working on. We would like to have an NixOS installer that can be booted with Microsoft keys by default. That will require us to include the shim of Red Hat and to sign it with Microsoft keys. So there is an open source project called Shim Review that any open source project can come to and say, oh, here's my binaries I want to sign because I'm distribution and I need to make this work on any potential system that ships with Microsoft keys. We expect this to go smoothly. We talked a lot with those people, and we understand how they think and how it works. So the idea is to have an NixOS installer that is signed by Microsoft keys that you can boot from, and then you have to plug your own keys. So either machine own keys or your own secure boot keyring, and remove Microsoft keys eventually.
What does it mean exactly that a machine comes with Microsoft keys? Where are these keys?
So if your system, if your machine comes with, I think it's the Windows Ready sticker, then it means they have the Microsoft public key in the UEFI security database. So it means that they will boot, if you are under secure boot, they will boot only Microsoft sign binaries. So that's annoying because we don't have the private key of Microsoft. So we have to go see Microsoft to ask them to sign stuff for us. And the shim is a trick to sign a single binary that can verify multiple other binaries. So Microsoft only has to care about the shim and not all the binaries you care about.
Okay, and that group essentially has access to Microsoft private keys in some way.
I think they have access to a backend to sign stuff and to approve requests for signatures, and they're distribution people. So those people are Red Hat developers, Ubuntu developers, etc. And they're like, it's a cross distribution coordination thingy where every Linux distribution care about the security of the whole secure boot ecosystem, and they work together to also open those possibilities to other Linux distribution or companies.
Okay. Last question on this topic. How can one help? Doesn't that require a lot of special expertise?
So it's true that I mean, maybe some years ago it required a lot of expertise, a lot of patience, some hardware sometimes. But I think we built a lot of test framework, I would say, tricks to test secure boot context, to test TPM2, to test UEFI variables behavior without having your own real hardware. So you can already get started building security stuff with all of that ecosystem without needing to maybe brick your computer, which I think is the most important thing you want to have to open up this type of work to everyone. And yeah, it's still a bit hard, but I think with the amazing work that the Arc Linux people are doing with SBCTL, for example, Secure Boot Key Manager, um, it's much easier to get started and to work on that without having to read a lot of specification documents. Also, we have this Rust. I mean, in the past, a lot of people wrote secure boot code or wrote a lot of security code in C, which is not the most funny things to do. Now we have Go and Rust, which are strong contenders for alternative languages to work on UEFI and secure boot and TPM2 and all that stuff, of course.
Okay, where should one go when if you want to start out and help? Should you just like talk to you, or how does it work?
I think talking to me is a very fast way to get redirected to the ecosystem you care about. But otherwise, I would recommend to read about Lenza Booty homepage documentation issues that contains a lot of information of where we want to go. I would highly recommend reading the Lennart Pottering blog post, which talk a lot about what is the ideal world where our Linux distribution have the same security level as Windows, for example, because we're not there yet. And then if you read all of that and you still have questions, reach out anyone working in that ecosystem, I would say.
Okay, thank you very much. Again, please ask questions if you have any as you go. I will try to put them into the show, into the program. So, okay, our main topic today is convergent configuration in NixOS. What the hell is a convergent configuration?
Yep. So it's a funny part of NixOS for me because some people. So what is NixOS? When you try to describe NixOS, some people will say it's a declarative operating system. It means you declare your stuff and then it gets into the state that you described. But we have a lot of things that are not really declarative, not truly declarative. For example, if you take your users on your system, if you remove a user from your NixOS configuration, what is the thing to do from a code perspective? Should I really remove the user or should I keep it because maybe it's a mistake? So the answer right now in NixOS is that we keep the user. We don't remove your /home/user if you remove a user from your NixOS configuration. And that's interesting because it means that it's not a declarative option, because if it was declarative, it would remove any trace of the existence of this data, this information. So we call this more like a convergent option. That is an option that we try to converge to. When you put a user, we will try to converge to the existence of that user and the configuration of that user. The same thing can be said about PostgreSQL databases, PostgreSQL users, Postgres MySQL users, etc. Whenever you have something that is related to state, you cannot really make it declarative because if you remove it, you have to remove the state. But NixOS doesn't never remove state because it's too dangerous to do it. Therefore, every time you have state, you need to converge to state. And that means that if you introduce a weird state, sometimes NixOS will fail to converge. Imagine that you corrupt your user that you removed from your NixOS configuration and you re-add it again to your configuration. The script that will converge to this new user being present again may fail because it's code and say, oh, this is an unexpected configuration I'm not used to. I don't know how to converge, how to get into the state you asked me for. So convergent configuration is really this ecosystem of options that we have in NixOS that seems to be declarative, but are not actually.
Okay, how do you know when you're using such an option?
So usually those options are supposed to be named with the ensure something prefix. So we say ensure users. That is, ensure that there is this user, converge to that user. Like it doesn't say that you should remove that user. It say that if this user doesn't exist, we don't care. If user exists, we're done. We don't have to do anything. If the user doesn't exist and we want this user, we will create that user. So that's true for a lot of users. That's true for a lot of options. But for example, the user.users NixOS module doesn't respect that convention.
So it doesn't. So it doesn't.
You don't
It's
have
called ensure users.
exactly. It's called user.users, and then you type your user. So it's a bit tricky.
Does that mean that every such ensure option is, in fact, completely custom to the use case?
Yep. Ensure option relies on custom code that will write a minimum state engine converter, basically. Everything has to do something like, oh, does this user exist? Does this state exist? Or If it doesn't create it, then register somewhere I created this state. And that's the basic algorithm. You have to converge any value, and then you converge the whole thing. But yeah, it's custom.
That sounds like a lot of hassle.
It is.
So
It is a big problem.
what's on your mind around this? What's the state of NixOS in that regard?
I would say there are two schools in Nix packages. There are school that for people that says ensure options in general is impossible to guarantee to people, and they're food guns, so we should just remove them. And we should just let people build their own ensure option mechanism. They could even, for whatever is worth, they can even use existing conversion systems. For example, Ansible or um, Terraform are examples of a convergent system to converge your infrastructure to a state. So maybe the answer is that we just remove all of them and we just plug existing tools, and we reuse the existing tool guarantees rather than NixOS that doesn't guarantee that. Then we have a second school. The second school says, but when you look at users, you rarely see someone saying, users.users is broken. Users.user works super well. So there is a difference between a low quality and a high quality converge script. The question is like, can we get all low quality converge script to high quality and call it a day? That's basically the second school mind. And for this, we need tooling to understand how convergent deployment works. We need tooling to assert what is the health of your conversions of state, and to like better encode them in NixOS modules. That could be a way to achieve this and still keep the convergent. And then we can introduce policy options that say, oh, this NixOS configuration doesn't contain any options regarding conversions. It's a purely declarative configuration.
Which
And
makes it kind of risk-free, right?
yeah, somewhat, because you will have the guarantee that if you roll back the system, because the worst thing about that is if you do a PostgreSQL migration of your Git instance, for example, Git is a Git server, open source server implementation like GitHub or GitLab. If you do the migration and then you roll back your NixOS system, which is one of the most promised feature of NixOS, when Git will run again, it will fail because the database schema has changed. The rollback doesn't roll back database migrations because it's state conversions. We don't have rollback for state conversions actions.
So it will run an older version of Git on the top of a database from a newer version, and we'll just don't know what to do, right?
It will just explode. It will just fail, and then you're faced with a situation where you're like, oh, now I need to restore my old backup to make this work again, or I need to upgrade. That you don't have the choice. So convergent option break rollbacks. If you don't have them, rollbacks perfectly works.
Okay, Brian has a question. Could NixOS possibly draw inspiration from tools like Puppet, as you said, Terraform or Ansible, for these cases like the users one, since Puppet does build on the ensure mechanism?
Yes, definitely. I think we could draw inspiration from Puppet, from Ansible, from Terraform. I think the biggest difference we have with those toolings is that designing a convergent option mechanism in Nix packages is a new exercise, is an open question, because those tools rarely have a monorepo of the word. They don't have this rich information that we benefit in Nix packages. And I wonder if we build smart NixOS module abstractions, could we make writing convergent option scripts extremely easy, extremely trivial, and composable? If we can do this, it would be quite interesting. Like I have some ideas on what we can use to make this more automatic, to make this more robust to users, and also fix the rollback problem.
So that will be a solution to the just make all of the migration code high quality.
Yes, that could be a possible solution.
What's currently, without having the tooling, what's the challenges with that? Couldn't we just say, hey guys, you're looking at this, don't you want to like write some convergence code?
We could definitely write documentation about how to write proper convergence code, like what are the classical pitfalls, what you should look for, etc., etc. The truth is, it won't work because I mean, if I may use my formal methods cap guy,
Please do.
I will say that the ideal word is a word where you prove that the steps you're taking to put a system in certain state to the ideal state are correct.
How
If you can,
realistic is that?
I would say, it's easy in very restrained, constrained cases. It's not hard in constrained cases. It's very hard in general cases. But the good thing is that if you squint at the NixOS module code, it can be transformed into an easy case ecosystem, because the NixOS module code is full of information, meta information about your service, about how it runs, about what does it need, about the PostgreSQL database that you need, etc. So mining this data, mining this knowledge could be used to build such a thing. But I would say also we don't use enough our file system features. We don't use enough. I would say, for example, imagine before activation you would take a backup of your whole system all the time. If you do this and you fail at activation, you can just restore the data that the backup you took just before activation, and then you would be back into the situation before the activation. That could
Right,
be
but that doesn't work for like 20 terabytes, right?
Yes, but you have a nice thing about file systems. They know how to do snapshots, and snapshots doesn't take a 20 terabyte backup. It takes only the delta that you need. So you could just roll back to that snapshot. But then the problem is that you roll back all the services at the same time. Maybe some service succeed and some service doesn't. So
You
maybe
have
what you
to
can
synchronize all of them across the switch.
maybe what you can do is to snapshot only services data and roll back only the service data you care about. With this line of thinking, you can identify that you have primitives. You have the snapshot primitive. You have the backup primitive. Sometimes you have backup that are specific to the database you're using. So Postgres has specific tooling to backup a database in an efficient manner. So you have a lot of primitives, and the question is, with those primitives, the NixOS module, can we build scripts that are always robust? Even if the logic fails, we can still roll back, because this is the most important thing you care about.
That sounds like a major research project. Is that something that people could tackle as a master's thesis or something like that?
So that brings me to an interesting point. I will share my screen. There was something in France called HDR, which is Habilitation à diriger des recherches. It's something that you do when you need to become someone who train people into research or direct those research, made by a person called Stefano Zacchiaroli. I hope I'm not butchering his name. He is he is a former Debian team leader and the co-founder of Software Heritage. And he worked on modeling of free open source packages and the relationship, component modeling beyond house boundaries, and source code of large force collection, which is related to software heritage. For this talk, we will only talk about the third section. The first section is about how to write convergent options in general. It's used for Debian, but they talk about like what do you have installed, what do you need to install, and like the state transition machines that you need to build, to make this work. And it also takes into account things like high availability. So when you want to run multiple services at the same time, or you want to have anti-affinity, say, oh, this thing and this thing cannot stay on the same computer. So a lot of things related to, I would say, cloud computing and this general question of deployment, so DevOps. And so Zacchiaroli in this thesis will prove correctness of configuration by using a certain formalism, deployment, state change, etc., etc. And I think the most interesting thing is like he also talked about how achievable it is. And he shows that in general, you have a lot of problems that are indecidable. So it's like,
Undecidable.
yes, it's not worth to try to solve them, but in certain restricted fragment of what you can do in terms of deployment, you could maybe have a chance to do it, and with a fast algorithm. So I would say this is the research path that someone should take and someone should build on to do the right thing about that. I can
Would that fit in the scope of a master's thesis?
Definitely. I mean, maybe honest, humble contribution could definitely fit into that. Solving the problem, probably not.
Okay, here's a question by Marvin. So
Yes.
maybe regarding your previous statement about file systems, maybe NixOS should ship with ZFS as a default file system for the future.
So recently we had a discussion to remove ZFS as a default file system in the installer images. Um, So the reason for why are related to all of that. The problem is ZFS is complicated to maintain. I'm a ZFS maintainer, by the way, in Nix pages. It's complicated to maintain and complicated to catch with upstream, the Linux kernel upstream, doing changes that breaks things, etc., etc. My personal opinion is that we have this bcachefs upcoming file system that is probably not going to be on par with ZFS right now, but I think that this is the path we should encourage. This is the development we should like try to go for, and maybe we could have bcachefs as a default file system in the future if it's stable enough, because it's definitely very related to. I mean, the author is a NixOS fan also. That's
That would help.
yeah, that would definitely help.
Okay. Oh, let me switch us back. I was trying to show your thesis better. Your screen better. Okay. So what are so you said this is a possible path to get there. What I mean, is anyone currently working on this apart from like you having that in your head?
So there is a big RFC issue in Nix pages that some people like are talking, where people are talking about that. We had a big problem during the release. Another one from infrastructure stuff, etc. Postgres SQL 15 introduced a breaking change in the way you bestow permissions to databases, and we use this ensure option for Postgres, which break every NixOS module when we default it to Postgres 15. And so it required people to step in and fix all of that, and it was like really hellish to put the list. And so some person was very interested into like trying to think about solving the problem more generally. I think there are multiple. So they commented on that issue. I can send it to you if you want.
Yeah, we'll post all the links of the stuff that you've been talking about after the show. Yeah. So
yeah, okay. So there is this issue where people are talking about that. There is also RFC. So RFC, I think it's closed by now. RFC 155, which is about NixOS migrations. So some
which
people
is
are.
essentially the same thing, right?
It is, but in my personal opinion, it's less ambitious because it's only about. It's about giving a up and a down script to every module, and that's a script that you will execute when rollbacking, and a script that you would execute when upgrading.
But it doesn't give you any guarantees.
Doesn't give you any guarantees. It doesn't give you. It's not automatic, because sometimes we can automatically generate such a script. It's not composable. It's not aware of what are your actually modules. You have to write custom code again inside this up, inside this down. So no one is working on the general problem. I would like to do it if I had time, but unfortunately it takes a lot of time to do things in life. But no one is doing that, yes.
Okay. What would be a good start? Do you think? How? So if you're, I mean, well, let me phrase this question differently. So how relevant is that problem to begin with? Because you said in the beginning we could just as well have completely pure configurations and just ditch state at all. So what's the problem with that?
So I mean, the problem is even if you use Ansible or Puppet or Terraform, they also have custom convergence logic inside their custom code, right? The difference is that you trust the provider, you trust the custom code that is written for this use case to just work. The truth is, like, I think 6 months ago, I don't know if it's still the case today, I tried to use Terraform to build a Proxmox VM on my Proxmox hypervisor. And the thing I got is Go segfault. So the thing is, the problem with custom code, custom arbitrary code written in a Turing complete language, is that it is too powerful, and if you don't handle all the cases, if you don't do the data modeling correctly, etc., it will fail. No matter if it is Puppet, no matter if it is Terraform, no matter if it is NixOS, as long as you don't introduce a completely different radical way to get around this, you will still have this curse of, if you write custom code, it has bugs and it can fail.
Okay. So how to go about it ideally. That I suppose that will impact a lot of commercial users because they will rely on larger databases. And in the meantime, what can we do? Because apparently we don't have that functionality rolled out in a wide way, in like widespreadly in a widespread
I
way.
think, yeah, I think easy ways to get started is to try to build easy prototypes around the problem. So, for example, you could replace the script that we use for conversions in Postgres by a REST binary that tries to be a bit general about this conversions. Like if you're able to replace the convergence logic for Postgres and MySQL and every database by the same REST binary that is general enough, that is abstract enough about this, you can start thinking about, okay, so now I have to make this REST binary very well tested. I have to account for all cases, and then I have to find where I can extract whether I can abstract the logic that is really critical to the steps that I have to do, and the steps have to be correct. And you could even plug formalification at some point there if you're abstract enough, and who knows what can happen. Um, but this is the idea. Really, I think the idea is to have like general tooling to do conversions in NixOS and replace bash script, bespoke bash script by that. And if you start doing this experiment and you try to improve things and you try to look how to generalize things, you have research question that you can solve, and you have an engineering problem that is solving the pain of a lot of people at the same time.
Yeah. So that I mean, more generally, are there more such hard problems? It sounds like a fairly hard problem to me, that we have in NixOS, because as you said, NixOS is promising a lot of properties that are quite unique in the open source ecosystem. And the further you get into like actually delivering on the promise, the harder it gets to do anything about like even improving on that state, right? Are there more such things that we may run into eventually?
So for this specific problem or over problems in NixOS?
This specific problem, but generally also, I mean, what else may come up as a surprise? Because to me, at some point, that whole topic was like, oh, that's actually a thing. We should take care of this, right?
So for example, imagine that you would want to replace Kubernetes with NixOS. If you want to replace Kubernetes with NixOS, you have to solve that problem of state conversions, because Kubernetes, like at the global level, perform reconciliation of your cluster with the real state and the desired state. Imagine we get there, then you have new questions. For example, NixOS is not really good at replacing Kubernetes because the activation phase is not aware of other machines. Imagine you deploy a new machine. You would like this machine to say, oh, I'm going to be deployed, so I'm going to be down. Please remove myself from the load balancer. And when you're back up, please add me again to the load balancer. We don't have good ways to describe this in NixOS at the NixOS level, because NixOS only cares about your NixOS system and potentially all virtual machines that are running on NixOS. But if we wanted to tackle this problem, we would need to have something that is meta NixOS, but understand multiple NixOS, and then also maybe to understand resources. So, for example, you might be interested to have a NixOS router module, and to say, oh, I have this router here, and I have this compute machine here, and I have this switch here, and configure everything from a NixOS expression, from a Nix expression. Sorry. So those problems are also open. We say we do declarative configuration. We say we have declarative infrastructure, but we don't really do declarative infrastructure of the whole ecosystem of an organization. We don't configure switches via Nix expressions. We don't configure routers usually via Nix expression. There are projects like I forgot the name, but there are projects that aims to build an OpenWRT style distribution based on Nix without systemd, without the NixOS stuff that relies on Nix expressions. That's an interesting thing. We don't have the same for switches. That's interesting. And then you can continue. Like basically, this whole thing is you take any piece of hardware, any piece of infra you can find, and the question is, why is it not running?
I mean, why can't we not run Nix on it yet?
Exactly. That's the question you answer. And we still have pieces lacking right now.
So we talked last time with Laszlo and Mick92 about NixOps and it kind of being dead. Why was NixOps not the way forward? So wasn't that supposed to be to solving that problem?
It's interesting you mentioned that, because NixOps contained a different, like it contained a convergent engine inside of it. because NixOps enabled you to manage your resources. So if you have the Amazon Web Services management gateway, you create it, you remove it. NixOps was responsible to run a convergence logic like Terraform, Puppet, etc., to bring it up or bring it down. The problem of NixOps is that I think the usage of Python and I think also like a lot of the core was not appropriate anymore. Made everyone who tried to work on NixOps give up. Like I wrote a NixOps plugin at some point in my life. I recently archived it because it's very hard to work on NixOps. But I think the NixOps idea is definitely conceptually the right one.
Okay, but it's not formal enough. Would you rewrite it in Lean or what?
Yeah, exactly. For example, no, I think the absence of types, even though we added types in Python 3, is problematic. But also the fact that we don't have C bindings to Nix makes it hard to do uh, like to do two-phase evaluation, because sometimes you have a piece of infrastructure that requires to know about another piece of infrastructure information, and this information is not yet known because it's runtime, it's dynamic. So you need to evaluate twice, or you need to find a way to have like to pose evaluation as you create the resources, fill the information that you're lacking, like the IP address of an EC2 node, and then give it to the evaluation thingy that was asking for it. So I think there is a lot of open problems in the NixOps code base that you can realize by using NixOps seriously. And I mean, NixOps is sufficiently simple that we can rewrite it in any other new language or ecosystem that we would like to use.
Okay, here's Matthew Crowan, who's running NixOS on my routers. There's Liminix too, which is to replace OpenWRT on MIPS machines.
See, this is the project I was missing the name. So Liminix is, yeah, definitely amazing. It also doesn't replace OpenWRT only on MIPS machine. It also replaces it on ARM64 machines, because the author is recently working on a new AP that I actually have also in my home. So I'm probably going to also send some peers for that.
Are you aware of Disnix by Sander Vandenberg? I
Yes,
mean, the distributed Nix.
yes.
So
So
what's the
this
problem
Nix,
with that?
uh, how to put it? I think the problem of this Nix is that it's also it comes from another age, like Hydra and all that stuff. So it's hard to get into that. Except if you want to spend a lot of time with this. But service-oriented deployment is definitely an interesting thing. I would like to see a better formal connection between the paper, the thesis I showed, and the service-oriented deployment architecture that this Nix is kind of showing. And how can we bridge the gap? And how can we? Because the problem is that you don't run usually your system, your laptop, as a service-oriented system. You don't say I have the terminal service, I have the desktop environment service, etc. You have this whole thing, and it's everything is in there. But for actual organization, for deployment system, etc., it makes sense. I think the hard thing for me is that it's hard to take this Nix and use it and put it in the spotlight to get people excited around it and work into ecosystem like NixOps actually. So I would definitely think that this Nix is something I would like to see more visible, but I don't know how to do it.
There's also an RFC, which is essentially born from Disnix, right? It's currently open. What do you think
It's
about it?
it's the Nix process management. So the idea is to introduce an abstraction for service management in NixOS, so that you can, for example, run Nextcloud not only on systemd but maybe on S6, maybe without any init system. So a lot of I think this is I really love this RFC. I really love this idea of we have an abstraction layer for the service management. The big problem I have is systemd is probably, unfortunately, the most comprehensive, complete service manager and init that we have in the Linux ecosystem. Any alternative like S6, which is quite already amazing and has a lot of features, doesn't have the same feature parity. So we will run into the problem of I have this service, it's hardened, it relies on the systemd feature. Can I transform its representation to S6 representation? And this problem is hard to solve, in my opinion, but it should be solved no matter what, because it just makes sense that I don't want to use the NixOS module knowledge not only for NixOS and systemd, but for any init script system. And that will unlock NixOS on embedded system, that will unlock NixOS in containers, that will unlock NixOS in a lot of places.
Okay, last question for today by Brian. Thank you very much, Brian, for so many questions. Do you think a proper Nix module system integrated into Nix as a language could help with some of these topics?
Yes, I have in mind the Nickel work on the NixOS module integration inside the language. I think how to put it. I think it's a hard question. It's an exploratory question. It's a research question. We don't have any research paper on what is the best way to design something like a NixOS module system. If we had this, I think it would inform us about how we should do it. Should we put some more primitives in the language? Should we make it more inside of the language of something more powerful, etc.? I don't know the answer. The only thing I know is that someone has to sit down and write the abstraction for that, and then it will inform us on whether DAL, whether Nickel, whether Q, whether it's fixed, whether other stuff can do interesting stuff in that area.
So again, someone has to sit down and do the work. Thank you very much, Ryan, for this great show. Very informative. The next show will already be tomorrow in less than 24 hours on Monday, November 20th at 10:30 UTC. We will meet Robert Hensing and talk about the module system. See you then. Thank you very much for joining. And until next time in the
Thank you for the
2023
invitation.
Nix Developer Dialogues. See you. Bye-bye.
See you. Bye bye.